All right, this is me solving the 7-1 additional practice worksheet. I'll try to go slow, and you can always pause the video if you need to. So draw a dilation of ABCD with E as the center. And we want the sides to be half as long. So you can start at any point, A, B, C, or D, and what you want to do is go from A towards E, towards the center, halfway, because our dilation factor is 1/2. So you just kind of ballpark this one. We're not going to use compasses or something to do that. So I would say about halfway is somewhere in here, and it's in this nice straight line. So that's A prime. Then I can go over here to B, and I would say between B and E in a nice straight line. Let's say there. Do the same thing, C to E, about halfway. C prime, and then D to E, about halfway. There's D prime. And then once you get done, you want to connect your points. And what you're hoping for is that this new shape looks just like the original shape and is it half as big. Another way to tell how great you did was to look at the lines like AB and A prime, B prime, and see just how parallel those two lines look. How parallel do these two lines look, etc. Okay, if they really look parallel, then you know you did a pretty good job. So that's number one. Number two, what is the scale factor of the dilation shown? So like we said here, it got smaller, half as big. So the first thing you want to focus on is what is the original and what is the new one. So the original is the one without the little tick marks. So this would be the original. This is the new one. Okay, so clearly the original one is bigger than the new one. So we are going to have a fraction like this. And then you got to kind of pick a side to figure out, well, how much smaller did like AD get to become A prime D prime? And so what I look for is I kind of make vertical and horizontal lines and say, okay, it was 1, 2, 3, 4, and 2. If I kind of think Pythagorean theorem, I could solve for AD, but it's 4 and 2. So now that I know this is 4, 2, I'm going to look over at the A prime, D prime, and I'm going to count, make my vertical and horizontal line, and I'm going to count 1, 2, and then this, it's kind of halfway between and halfway between, so that is 1. So that's 2, 1. So we went from 4, 2 to 2, 1. This is half as big. So the scale factor is 1/2. All right, moving on to number 3 and 4. You can see I already have set up my A prime, B prime, C prime for A, B, and C. And I have a dilation of the scale factor of 0.75. That tells me right there that number is less than 1, so these numbers are going to get smaller. And what I really need is a calculator because I need to multiply all of these numbers times 0.75. If it was 0.5, I could easily find half of these, but multiplying these by 0.75, we want to go ahead and use a calculator for that. So I'm going to do 4 times 0.75, so 4 times 0.75, and -3 times 0.75. Okay, so I have 3 and -2.25, so A prime is at 3 and -2.25. Okay, B, got to multiply B times 0.75, so I'm going to clear and do 6 times 0.75 and 1 times 0.75. So that is 4.5 and 0.75. And then for C, I'm going to go ahead and clear it and do 10 times 0.75 and -1 times 0.75. And that is 7.5. And I'm going to go ahead and erase that. -0.75. So, got smaller, all these numbers. Just calculate, multiply, and you have the new coordinates after a dilation of 0.75. Okay, for a dilation of 1.5, since it's more than 1, these are going to get bigger. Again, I just need to multiply all of these numbers times 1.5. So get my calculator here, clear it, and do 3 times 1.5, which is 4.5, and 0 times anything is 0, so I won't waste my time doing that. And I got 4 times 1.5 and 2 times 1.5. So y is now 6, 3, and clear 6 times 1.5 and negative 2 times 1.5. 9 and negative 3. So again, when you have a number less than 1, your numbers are going to get smaller. If you have a number more than 1, your numbers are going to get bigger. And it's just a simple multiplication. All right, number 5. Charles enlarged a small quadrilateral. So here's the original MNOP. It got bigger. You can see the new one here. It's for an art project. How are the angle measures of the pre-image? That would be the pre-image and the image related. Well, if you just look at angle P here and you look at angle P prime here, I hope you see that those are the exact same measure. So I would write the same. How are the measures related? They're the same, or you could say equal. So angle measures don't change when you make something bigger or smaller. It says, what is the scale factor of this dilation? So notice this has actually a nice line PO to use to calculate that, unlike this one here where we kind of had to do the vertical and the horizontal because this is slanted. Okay. With this one, we can just count from P to O. That is 1, 2.5. Write that down. And now P prime to O prime, that is 1, 2, 3, 4, 5, 6, 7.5. So what did we multiply 2.5 by to get 7.5? Well, what you want to do is just divide these. If you take 7.5 divided by 2.5. So clear that, 7.5 divided by 2.5, and you get 3. So it's 3 times bigger. That is my scale factor. Okay, how are the areas related? So what we learned is that areas don't just, let's say, get 3 times bigger. Okay, perimeter would get 3 times bigger. Okay, but areas are going to get 3 squared times bigger. Because when you talk about area, area is length and width. There's 2 dimensions here. So that's why we need this 2. So the areas are related. It's going to be 9 times bigger. So if this original area, let's say, is 10, then the new area is going to be 9 times 10, which is 90, for example. So they're related by a factor of 9. Okay, so there is the 7-1 additional practice worksheet.